All right, in this lesson, we're going to go back and we're going to recall real quick about what it means to be in the midpoint. The midpoint, remember, is the point that is equidistant excuse me, from either of the endpoints. So we have talked about midpoints before. We know that it is the point in the middle. We briefly talked in the beginning of the unit, at the beginning of the year, about being in between. And so what we're going to look at today is what does it mean to be in between? What is the fractional distance, something other than halfway? So we're going to start with just a single one-dimensional number line, and then we'll move on to into a two-dimensional coordinate system in just a minute to see what the difference is, because really it all comes back down to this single number line. It's just either the number line is going to be horizontal or the number line is going to be vertical, depending on whether you're looking at the x-axis or the y-axis. So this is really the foundation for everything, how to do the rest of the problems. So Jaren's house is located at mile marker 2. So I'm going to take right here, and I'm going to put a J for Jaren. His best friend Marcos lives at mile marker 20. So he's right here, and we're going to put an M. What is the distance between their homes? So the distance between their homes, if you look on the number line, the distance from 2 to 20 is the difference between the numbers. So 2 minus 20 is 18. So there is 18 miles of difference between the two. So this is 18 miles. So Jaren and Marcos like to meet up at the Dairy Queen located exactly halfway between their houses. So halfway, we know that half of 18. Now, here's what you need to recognize. It is 9 miles away. Okay, it's not at 9, it's 9 miles away. So the question then says, at what mile marker is the DQ? Well, it's 9 miles away from either one of them. 9 miles away from Jaren would be 9 plus 2. 9 miles away from Marcos would be 20 minus 9. So it would be halfway. So the Dairy Queen is right here at mile marker 11. Okay, so be careful with that. What students always want to do is they always want to put it at 9. But you can see 9 is not halfway, right? It's closer to Jaren than it is to Marcos. So Jaren's Aunt Lisa lives 3/4 of the way, okay? So of the distance, 3/4 of the distance from his house to Marcos' house. So Jaren's Aunt Lisa lives 3/4 of the way from his house, which is Jaren's. It's from Jaren's house to Marcos' house. So the distance from Jaren's house to Marcos' house is 18, and 3/4 of 18. Okay, if you don't know how to do that, let the calculator do the work for you. It would just be 3/4 of 18. Well, 3/4 of 18 is 13.5. So 13.5 it's 13.5 miles away. So it's 13.5 miles away, right? It's not at 13.5. It's 13.5 miles away. So 13.5 miles away from Jaren's house. Well, Jaren starts at 2, not at 0. Right? So 13.5 miles from Jaren's house would be 13.5 plus 2, which would put Aunt Lisa's house at 15.5. So it would be at mile marker 15.5. So that is Aunt Lisa's house. Marcos's grandmother lives 2/3 of the distance from his house, Marcos's house, to Jaren's house. So from Marcos's house. Okay, so we're going to go 2/3 of the way from Marcos's house. So zoom this out a little bit. So 2/3 of the distance from Marcos to Jaren's house. So again, it's 2/3 of the 18. So 2/3 of 18. If you don't know how to do that, do this. 2/3 of 18. And you get 12. So she is 12 miles away, not at 12. She is 12 miles away from Marcos's house. Now be careful here. Marcos is at 20. She's 12 miles from Marcos. If I add 12, I'm going to go this way. I need to subtract 12 because she's 12 miles away from Marcos's house. That puts me at 8. That is where his grandmother is. She is at mile marker 8. And then lastly, we have if Jaren and Marcos' school is located halfway between Aunt Lisa and the Dairy Queen. Well, that means we need to know the distance from Lisa to the Dairy Queen. So from Lisa to the Dairy Queen is 15.5 minus 11. So 15.5 minus 11 is 4.5. And she is halfway. So she's half of the distance, and the distance was 4.5. So half of the distance, if you take 4.5 and divide that by 2, you get 2.25. So she is 2.25, again, not located at 2.25, but she's 2.25 miles away. Now in this case, because it's halfway, it doesn't matter whether it's the school is between Lisa, whether we're leaving from Lisa's house or the Dairy Queen, because it's halfway. So the Dairy Queen's on the left, so I'm going to add 2.25 to the 11, and 11 plus 2.25 is 13.25. So the school is at mile marker 13.25. It would be right about there. You can see that's about halfway. So the numbers don't always come out pretty, but you can see what you need to do. Okay, now let's look at what happens when you put this on a number line or on a grid, a Cartesian grid. Okay, so Geotown is a small town in Texas. Main Street stretches from Geo High School at negative 1010. So here is Geo High School, and all the way to Pythagoras Park at 2, negative 6. So we are at 2, negative 6. That is the park. What is the length of Main Street? So if I want to know the length of Main Street, then you could use the distance formula. So one way, you could use the distance formula, and you would do x2 minus x1 squared plus y2 minus y1 squared. I like to write it out and then go back and plug in my numbers. So x2 minus x1, y2 minus y1. Fix all those positive, those double signs, and so we would get, this would be negative 12 squared. The negative's not going to matter. This would be 16 squared. So the square root of 12 squared plus 16 squared is 20. So it is 20. Now I want to show you something just so you can see it. If you are familiar with Pythagorean theorem, then this is a little bit easier to do. And you're going to find that we use the concept of slope all the time. Notice that that is a diagonal, or if you notice this, look at all these horizontals and verticals, you see that right triangle right there. That means you can use Pythagorean theorem. So if you notice, this side has a length of 12 and this side has a length of 16. So you could do Pythagorean theorem. 12 squared plus 16 squared is equal to the length, or we'll call it little d squared. See, doesn't that look familiar? Because I'm going to end up taking the square root of both sides anyway, and you're going to get that 20. So Pythagorean theorem, if you remember how to do Pythagorean theorem, is a really nice shortcut to not have to think about the distance formula. We've talked about that before. Now, Trigo's Diner is located at the midpoint of Main Street. Now we know how to do the midpoint. You could, in order to do the midpoint, you could do this. You could do negative 10 plus 2 over 2, and the other point would be 10 plus negative 6 over 2. So you get negative 8 over 2, which is negative 4, and you get 4 over 2, which is 2. So it would be at negative 4, 2. Now I want you to see this though. Look here. If we continue to break this into pieces, right? Look at that. So I broke that in half by going half of 12. So I went over 6 and then I went up 8. That's halfway, right? Half of 12, which was the whole distance. If I broke this into horizontal and vertical components, then it's over 6 up 8, half of 12 and half of 16. And that put me there. So I could use the formula to calculate that, or I can get it from the graph. So it all kind of depends on what you are accustomed to. So one of the things that I like to do when I'm doing this, especially when we get to these numbers that are 3/4, is I like to go back to my rise over run. I know slope, I know how to do it, and I want to go in and I want to see how that works. So let me show you. Quad Mart is located 3/4 of the way down Main Street. What are two possible locations for Quad Mart? Now, the reason there are two locations for Quad Mart is I didn't say from where, right? If you remember, on the other page, we said she's 3/4 of the way from Jaren's house. She's 2/3 of the way from Marcos's house. I told you where we were leaving from. But in this case, I said 3/4 of the way, but I didn't say 3/4 of the way from where. So that's why you have to be careful. Now, 3/4 of the way. Here's how I like to do this. Because 3/4 of a diagonal distance, you don't want to do 3/4 of a diagonal distance. It's hard to count. How do you count 1, 2, 3 on this diagonal distance right here, right? So here's what I like to do. I like to take the entire length, which is this piece right here. I want to take that entire length. Let me zoom in here. I want to take that entire length and I'm going to break it into 4 pieces. Well, 12 broken into 4 pieces, 12 divided by 4 is 3. So it would be over 1, 2, 3, over 1, 2, 3, 1, 2, 3, right? 16, this vertical piece broken into 4 pieces would be 4, 4, and 4. So if you come in here and you kind of look, I know it starts to get messy, but look at this. So 3/4 of the way. So let's go over, so we go over 3 up 4, over 3 up 4. That's 1/4, 1 stair, 2 stairs, and then 3 stairs. So 3/4 of the way from the park is this point right here, which is at -7, 1, 2, 3, 4, 5, 6, -7, 6. Okay, 3/4 of the way the other direction, you would start and you would go 1, 2, 3 of the 4 stair steps from the top, right, from the high school. So I broke it into 4 stair steps because it had a 4 in the bottom. Okay, so it was 3/4, so I broke it into 5 of them. So the other stair step or the other location where the Quad Mart could be at -1, -2. Okay, so it could be in either location because I did not give a place where we were leaving from. Okay, now the next one's gas station is located 2/3 of the way from Pythagoras Park to Ellipse Pool. So Ellipse Pool, that's a new location, so that's at 8-3. So here is Ellipse Pool. And we want to go 2/3 of the distance from the pool to the park. Let me double check. It says, no, 2/3 of the way from the park. So we want to leave from the park. So I'm going to break it into thirds because it says 2/3, right? So I'm going to break this slope into thirds. So I'm going to break it into its horizontal and vertical components. That's the easiest way to do it. So break it up into its horizontal and vertical and count. 1, 2, 3, 4, 5, 6. This is 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a rise of 9 and a run of 6. Now we want to do 2/3 of the way. So I'm going to break the 6 into 3 pieces. Okay, break the 6 into 3 pieces. So that would be 2 and 2 and 2. So there are 3 pieces there. And then I'm going to break the 9 into 3 pieces. So you've got those pieces too. So we're going to go over 2, up 3, over 2, up 3, over 2, up 3. Notice I have 3 stair steps. See? I have 1, 2, 3 stair steps. Why? Because it said thirds, 2/3. So I broke it into 3 stair steps. Now I want to go 2 of the stair steps from the park. So I go 1 step, 2 steps. So that second step is at 3, 4, 5, 6, 0. And so gas station A is at 6, 0. Okay, break everything into its horizontal and vertical components. It makes it so much easier to keep up with. Okay, now it says the pool and the park are endpoints of reflexive row. So the pool and the park, so this is Ellipse Pool and the park are endpoints of reflexive row. So it says how long is reflexive row? Well, let's go back to now what we know is that we can use Pythagorean theorem. So Pythagorean theorem then would be 6 squared plus 9 squared. So if we have then the square root of 6 squared plus 9 squared, then we would get that it is 10.8 units long. 10.82, depending on what I tell you to round to. I didn't give you anything to round to. On a test and a quiz, I will always tell you what to round to. But 10.8 is good enough, okay? So I wanted to know how long. You could have also used the distance formula with these 2 points, okay? We know that the pool was at 8.3. We know that the park is at 2 -6. So you could have also used the distance formula between these two. Now look, notice the distance. How far is it from 2 to 6 on a number line? It is 6. And how far is it from -6 to 3 on a number line? 9. Okay, so using the distance formula is the same thing as using Pythagorean theorem. It just makes it a little bit shorter. Okay, then Euclid, famous mathematician, Euclid's department store is located 3/4 of the distance from Circle A to Trigo's Diner. So Trigo's Diner we don't have Trigo's Diner. So you would find out, so I would need to know where Trigo's Diner is to be able to do this. I'm sorry, I don't have that. You would need to know where Trigo's Diner is, and then you would break it into 4 pieces, count 3 of the 4 steps, and then you need to, and then that would mark where the department store would go. Okay, so you would break the stair step into 4 pieces, but the problem is you need to know where Trigo's Diner is to be able to do that. Okay, so always break it into horizontal and vertical components. That makes it much easier. And then go that distance, break the horizontal and vertical components into the number of pieces it says, and then count that number of stair steps from the location that it says, from Pythagoras Park, from Main Street, from those 2 places. So always pay attention to where you are leaving from.